Hello all, welcome to Java in programming series. I'm Dr. Yashwant Dongre. In session 2, we are going to cover data types and literals. Java data types. The data types tells the compiler about the type of data to be stored and required memory. Based on the data type of variable, the operating system allocate memory and decide what can be stored in reserve memory. There are two types of data types in Java. Namely, first is primitive data types and second is non-primitive data types. In first type, the primitive data types includes boolean, character, byte, short, int, long, float, and double. In non-primitive data type, the primitive data types include classes, interfaces, and arrays. Here Java is a statically type, also a strongly typed language, and this means that all variables must be declared before they can be used. This is how data types are there. Primitives at one side, non-primitives are at another side. In primitive, booleans and numeric are there. In boolean, only boolean is type. In numeric, character and integral are two types. In integral, floating and integer. In floating, float and double are there. Two data types are there. In integer, there are byte, short, int, long. They varies in a storage and they varies in a range. So that byte have very short range, short have again short range, and integer have little bit more range, and long is very uh, big in capacity. In non-primitive, string, array, etcs are there. In primitive data types, first byte is size. It takes 1 byte to store in memory. If you declare 1 byte variable, it will take 1 byte in memory while program execution. This stores whole number from -128 to 127. In this way, total 256 numbers, uh, 256 size is there. For example, if you want to store numbers which are between this range, like I want to store 100, and which number cannot exceed 127 at all, or I would like to declare or use -90, which cannot be less than -128, so that it is better to use byte in that case. It is normal practice by programmer that we normally declare integer for the most of the time. If I have a class of 60 and I would like to store roll number, it is best to declare that roll number as byte, because it will not exceed 60 to 100. Then normal practice, and which is not good practice, that normally developers, programmers declare integer for general purpose, but whose range starts from -214743483648 this range, -2 plus 21474833647. This is huge range is there. So that for the long, again before it it will take a 4 byte. Means if you have a requirement of only 100 or 200 numbers, and if you are declaring byte, sorry, if you are declaring integer in that case, where requirement of memory was 1 byte and you are using 4 byte, so that 3 byte at the runtime will get wasted. Instead of it, you may have option between byte and integer of using short. Short takes 2 bytes and store whole number from minus 32,768 to 32,767. In this way, nearly about 64,000 numbers. This range you can store in the short. Again, if possible, instead of integer, for general purpose, use where millions and billions of records are not there. In that case, you can go with short. Long is again taking 8 bytes, where store whole number from, this is very huge number, this is very big number, this minus 9x to plus 9x, this is big number, and long will be able to store in this way. This is about a whole number or complete number. Now we will see about a fraction of number. To store a fraction, we have two options. First is a float and another is double. Float again have capacity or memory requirement of 4 bytes, where double have the memory requirement of 8 bytes to store in the memory. So that float 4 bytes store a fractional numbers which is sufficient for storing 6 to 7 decimal digit. 6 to 7 decimal. So that double have again store fractional number sufficient for storing 50 decimal digit. 15 decimal digit. Total 15 decimal will be there. Out of that, some fraction will be there and where complete number will be there. In two sections you can store, but total size will be of 15 decimals. Boolean will store 1 bit, not byte even. Only 1 bit is required for Boolean, which may indicate either it is a true or false. Only true or false, 1 or 0, it is like it. Again, character have 2 bytes. Store a single character, letter or XC value in it. Byte. This is very basic unit of storing number. To store a number, this is very smallest range. Byte data type is a 8-bit sign whose complement is integer. Minimum value is, we have seen, that is a minus 128, which is a 2 raised to 7. If you calculate 2 raised to 7, you will get 128. So that minus 2 raised to 7 2, which can be a up to 2 raised to 7 minus 1, because this, the default value is 0. 0 to 127 is total 128, and from minus 1 to minus 128 is again 128. In this way, total 256 storage capacity is with this byte, and this is calculated through the total 8 bits are there, and 2 raised to 7 will give you 8-bit capacity. Then byte data type is used to save space in the large arrays, mainly in a place of integers, since byte is 4 times smaller than an integer, and bytes are especially useful when you are working with a stream of data from a network or file. For example, byte A equal to 100, byte B equal to minus 50. For smaller capacity, byte variables are important. Sufficient, not important. For example, byte data type. For example, I have class main, public static void main, byte range. Range is 124, system out println 128. We have indicated its range is minus 128 to plus 127. Let us check through the program. Let us check through the program. Let us have same program in Eclipse. Let us start with Eclipse, and we will create again simple Java program which will show us the how to use byte one by one, all literatures like byte, integer, short, all we will see in the programs. Okay, Java in programming series, we have this project we have already created. This is default package in SRC. There is first program is already there, so that in the SRC folder you go and add the new class. Just we will give this class name as a literals. Also we will include public static void main automatically. Here you can add the statements, so that here I will declare byte, we can say range, so that in a range we will add range equal to say 100. Let us check system out dot println, check for this, either this I want to print 100, so that this byte is useful. So this run again as a Java application only. See, 100 I am assigning to range, this is giving 100. For say I would like to use minus 128, will this accept byte? What is range of byte? Range of byte is minus 128 to 127. So that 100 is accepting, this program is accepting. So that if you see boundary condition minus 128, this should accept. Go. Yeah, good. 128 minus 128. Just boundary, check the boundary condition. 128, 129. Will this accepting? Giving red. Type mismatch. Cannot convert from integer to byte. Means minus 120 up to minus 128. Number up to minus 128 are byte. If you try to use 129, it is integer, so that integer cannot be converted to the byte. See, try to run, this will give error. Yeah, okay, proceed. See, exception in main, Java lang error, unresolved compilation problem, type mismatch, cannot convert to the this line number, including line number we are going. And if you click on this, you will get highlighted on particular. Even again, if you do 128, this will accept, this will accept. Again, for positive numbers, 127 is a range up to maximum 127. This will take, yeah, see, 127. Even 0 is also there, range 0 is also okay. 0 is also byte. 127 is also byte. See here, just go increase by 128. This will give error. See, this will give error as compilation error, unresolved, cannot convert integer to byte. So that 128 will be, means the range 1 minus 128 to 0 means minus 1 to minus 1 to 0 to again 1 to 2 to 127. These are byte. These are bytes. What is about remaining? So that if you want to go toward this minus 129, 128 minus 130 means less than this number, less than minus 128 should go in the integer, and after this 120 from on this line number of line 128, 129 and 130 like number means number onward, this will go into the integer range. Means if you start saving, if you try to save these minus 129, minus 130 or my 128, this range, this will be treated as integer, and your program will look for conversion from byte to integer. So that this range particularly is for byte. Now this to these number less than these numbers greater than these are treated as integer. Okay. About a short data type is a 16-bit sign two's complement integer. Then minimum value is minus 32,768, which is driven from minus 2 raised to 15 because total 16 bit are there. If 16 bits are allowed, 16 bit number is there, you just raise it by minus 1. If 16 is n, so that n minus 2 raised to n minus 1, calculate it, that will be the range given for particular bit. Or if it is a 2's complement, means it is a 2 raised to this n minus 1, it will give as 32,760, and plus again this 2 raised to 15 minus 1, this will give you number exactly minus 1, because this number is starting from 0. All positive integers are starting from 0, negative integers are starting from minus 1. 0 is coming under positive integers. This is topic of debate. So that total number 2 minus 1 will give you positive maximum values. So that short data type can also be used to save memory as byte data type, and short is 2 times smaller than an integer. It is probably the least used data type, Java type, and default value is 0. And so that for short example is, apart from greater than 128 value 127, see its range is plus 127, 0 to 127 goes into the byte, then 127 means 128 to all 32,767 will go into the short. Means if you declare short s equal to or r equal to something, so that it must store number less than 32,767, number must be less than, and which must be greater than minus 32,768. So that 20,000 I want to store, this is greater than 32,000 minus 32,768, so that such a numbers we should go into short. Exact boundary condition for short also we will test. So that come to the program, we will go to the Eclipse editor, check for the short. Its range is 32,767 to again 32,000 68 and 67. Okay, this is 68 because starting from -1 to minus 32,068 to 0 to 32,767 because this is starting from 0. This is nothing but 2 raised to power 15 bit, total 16 bit, so that it is a 15. This is the result from this to this. So that range we will assign like 20,000 I would like to store. No problem, this will print. Let us see, this will print, no problem, because this is within this range. See, excellent, 20. But if you try to exceed this range, for example 32,767, this will allow, no problem. See, 32,076, this is running, displaying. If I go one number more than this, see, this is going, just run and see the error. See, integer to short cannot convert. Compilation error, unresolved compilation error, cannot convert from integer to short. Means this range is treated as a short. This range is treated as short. Means for 127 to 128 you may use, right? Then 32,000 key range you may go for the short. Otherwise for all number integer is there, for all lower range. Even though for I would like to store 100 byte is a option, but I can use a short, no problem. Check this side boundary condition. Minus 32,068 up to 68 is valid, so that run this. This is running. One number less than this, negative number is always less than, which is a by looking increase it by 1. In minus number it is a lesser than it. If you make lesser by 1 means 32,769, it will go to the, see this, integer to short, means this will be treated as integer. This will be treated as integer. This is about short. In integer, it is normal practice by programmer and developers. We don't care about actual range. We directly go for the integers normally. If you want to write a memory efficient program, optimized program, don't do like that. You go with the actual range. Now if your numbers are 32 bit, use integer. 32 bit means 2's complement 2 raised to 32 means 2 raised to. If 32 bit means 32 is n, so that 2 raised to n minus 1. Do calculation and fix the range. If you calculate 2 raised to 31, this will be a 2147483 this is number. Similarly for positive numbers, again do this, and due to range is starting from 0, you minus 1, do the -1. This is minimum range, this is maximum range. So that integer is generally used as default data type for integral values unless there is a concern about memory. The default value is 0, and example integer a is a something 1 lakh, 1 lakh, and integer b is a, for example I would like to store 1 2 3 4. This is 2 lakh minus 2 lakh I would like to store, plus 1 lakh I would like to store. All these both range are out of a short, even not byte. So that use integer for 2 lakh, 1 lakh, minus 3 lakh, like that. Total, if you see, total 10 digit positive and 10 digit negative numbers with this range can be stored, so that in some cases if 6 digit number I would like to store, your short will not be work. So that let us check for boundary condition of this. Come here, declare integer, check for the range. Okay, now see here, range is minus 2, this is 2 plus minus by 1. Integer. Now I would like to store 1 lakh 1 2 3 4 5 6. Will this work? This is in lakh, short range is in thousands, so that see this. Okay, good. Even I would like to be 10 digit number, and which is starting from, for say, instead of 3 it is a 4, and 1 2 3 4. This will not support. See this. Even exactly this size will get supported. This range will get supported. But this is maximum range. This is, if you tackle with a little bit more value, or if you go with 49, this will not support. In case of positive number, if you exceed this range is okay. If you go with this one, increase 1 by 1, so that this will not be supported. See this, run. Okay, increase by 1, boundary condition, run this, you will get error. Unresolved compilation error you will see here, and integer is out of range, and exactly if you click over this line you will get highlighted this where error is. Good. Come to the PPT. Long is 64 bit, and how to calculate 64 bit? Again, 64 is n, so that 2 raised to n minus 1 if it is a 2's complement, but it is in Java 2's complement numbers are there, so that 64 bit minus 2 plus 2 raised to n minus 1 minus 1, this will be the range, so that 19 digit number you can store, maximum 19 digit number you can store. This type is used when wider range whole numbers are needed. Means, for example, just before we have seen 9 digit 10 digit numbers we are allowing with range specified. Here we can go with a 19 digit number with this range. This is a minimum value, this is a maximum value, these to this range, where default value is OL. If you are declaring number is long, so that its value assignment is always L. Capital L you need to long. For example, long A equal to something number, L indicates it is a long. Let us see in a program how this is working. Let us have a boundary condition for this number. Control C. Go here. Long. Why? This is within range but not allowing this number. This red is indicating no, this is not out of range. This is assuming this is integer. Default, simple solution. Write L in front of this. This is postfix by L. Postfix by L means you can print this and see this is giving you number. So that its range is starting from this number minus 2. Again 2 raised to 30 67 minus 1. This will give this number minus this. Check this boundary condition. If I assign this L, this will not accept. This is a negative range. This is lowest number long is accepting, so that minus and this is long. So that let us see, run this. Great, this is accepted. This long digit number, total digits are 1 3 3 6 9 12 15 18 19 number digit number, 19 digit number. This is allowed by long range. Let us check positive maximum number. This 8 is not allowed. Here 7 is required. If it is 7, this will be allowed. This number, this is allowed. Increase by 1 will not allow. See, not allowed. Unresolved compilation error. Literature this of type long is out of range. If you remember, at the time of short to byte, it is suggested that integer cannot be converted to byte or integer cannot be converted to your short, or long cannot be converted to integer. But here conversion is not problem. This is out of range. Means keep in mind everyone, Java numbers accepts, or Java compiler accept numbers up to maximum 64-bit, and its maximum range is this. This is a maximum range is 807. See, 92233720368 5477 5807. This is maximum range. If your number, if your program, if your project generating any number greater than this, like 808, this is not accepted in Java as on date. As on date. So that this is maximum limit of Java, 19-bit numbers, which is specified range is maximum to maximum for the working with Java. Floating point, for example, this is till the these four variables, integer, short, sorry, byte, short, integer, and long. They are for the whole numbers. Now let us deal with a floating point. For example, I would like I have some uh, calculation of weights. For example, some item have weight of 4.5, 4.5, or 4.05, or 4.25, or 20.95, or 80.687. Means whole number is fixed, but precision required are some digits, some up to some digits. So that float data type is a single precision 32-bit IEEE 754 floating point. Are useful when need a fractional component but don't require large degree of precision. Float is mainly used to save memory in large array of floating point numbers, and default value is 0.0 yap. Means to indicate particular number is a floating point, you need to write yap at the end. Like default value 0.0 yap. Yap is there. Yap is mandatory to indicate particular number is a primitive data type is a float. Float data type is never used for precise value such as currency. For example, float f1 equal to 2.3.323.45 yap. Example, float number equal to 42.3 yap, and you can print. You can see this will print. Let us go to the Eclipse and check this float. This float variable name is something number, so that we will go to float number equal to default. It is something 4.5 yep. I would like to use, and this number I would like to print. Will this work? Will work. If I will not write this floating number is 4.5, this I will assume, so that this will give some error like unresolved compilation. This is not converting from double to float, because if you do not indicate this is f, this will treat this as a double. This will be treated as double, so that simple, if you do this double, this will allow, this will allow. So that if it is a floating point, it will be a f is a indication of f is a must. Then double data type is double precision with a 32, sorry, 64-bit. Here if you see, floating point is a 32-bit. It is just like equivalent to integers are 32-bit, floating points are 32 bits, longs are 64-bit. Here doubles are 64-bit. Means it is a whole number is long, same number you would like to convert to double, sorry, to the floating point, so that floating point is a double for 64 bits. It is also mentioned in 7.5 floating point of IEEE. This data type is generally used as default data type for decimal values. Generally the default choice. Double data type should never be used for precise values such as currency. All transitional math functions such as sine, cos, square root returns double the values. All these functions will return the values as double. Means whenever you would like to fetch the result of sine, cos, square functions, return type variable means such a return types must have stored in double variables. When need to maintain accuracy over many iterative calculations, or are manipulating large values numbers, double is the best choice. Default value is 0.0 d. Here you need to mention d. If you don't mention, this will default will be treated as a d. so that double d1 equal to something, so that if you don't mention d, then default this will be showing as like d. Normally if calculations like I have some variable like pi r a pi, I know 3.1416 are there, then r is 1.10.8 and I need calculation of r square, so that p area is pi into r square, so that in this way you can calculate. The same program we will try. We will see output of pi, such a program, area program, so that we have here double pi area and something variable for taking radius is r, so that area is nothing but pi into radius square will be done by r into r. Also r is to power 2 using math function can be done. Power function can be used or square function can be used from java.math library, but for initial purpose we will not go to the such a specific libraries like maths, so that here we will see by some simple way, so that here is issue of variables are not assigned with values, so that pi is, we know this is 3.1416 is value for pi, and r we have something 1.8 we want to use, so that here we will get output as area. Area is 3.66 in 0.436224 precision. Then boolean simply stores true or false, 1 or 0. Only 2 bit, sorry, 1 bit is required to store. 1 bit is always either true, false, 1 or 0, like that. Boolean data type represents 1 bit of information and there are only 2 possible values such as true, false. This type is used for simple flags that track true, false conditions. This is the type written by all relational operators, as in the case of a less than b. Also the type required by conditional expressions such as if and for. Default value is always false for such boolean variables. For example, boolean 1 equal to true if you mention, or if you just say boolean 1, it will give you as a false. So that booleans, let us check boolean b variable and we will see what he is executing. Even we will try it in if. Same program we will do. Declare here as boolean b, just and see what is b. We claim b default is false. Let us see. B equal to, not at all. B equal to, if you declare false, no problem. This will print false. If it is true, then true, no issue. If it is false, try to use it in if b and write this as b is false. Otherwise, else else assign b as true. If b is a true, then this is a true, else b is false. Let us check. Yeah, true. B is a true, so that b is a true. If it is a true, then only this will go in this condition. Otherwise, if this is false, this will go into the false statement. See this is false. Means in a if conditions also your variables are very important. This type of variable is important. Character. This character data type is a single 16-bit Unicoder character. Java uses Unicode to represent characters. Minimum value is /u 4 times 0 in single quote or simple 0. Characters default minimum value is 0 and maximum value is up to 65,000 because it is 64-bit. If you calculate it, you will get a value of 65,535. Character data type is used to store any character, and his example is character letter A equal to A. ASCII character and codes. ASCII character for American standards. Let us see how to declare characters. Go to our editor, Eclipse. Don't need this. Character ch. Try to print ch. Until and unless you initialize, you cannot print it. There is no provision of default values, so that if I print ch it's A, this will not allow. If you want to ch it's A, character literal R, put it into the single quote, then this will be treated as character. I want to store A in variable, character variable ch. I am printing ch. Let us see output. A is printed. If I am storing directly 1 or 0, what will be the possible output? If you see, this is something different things are getting printed. So that what are these different things? This is nothing but a, if you see here, characters, ASCII characters and code. We will back to the ASCII, because in character if you store 1 as a number, this will goes to the ASCII character. What are such ASCII character? ASCII stands for American Standard Code for Information Exchange. Each character is assigned specific numeric value called as ASCII code. ASCII codes are decimal number represented in 7-digit, and ASCII codes are available only for limited number of characters ranging from 0 to 127. Basically, the ASCII codes are used while programming when it deals with the characters. This is a table for ASCII value. This is character range. This is character range. See, if decimal 0000 character, there is a, up to this there is a space. After this, these are the character and these are the ASCII value for in decimal, in hex, in then Unicode. Latest coding system of the characters followed worldwide. The Unicode is a wide representation of characters in numeric form. The code contains hexadecimal digits ranging from 0x000 up to 0xFFFF. Advantages of Unicode are more efficient coding scheme than the ISO or IEC. It supports uniform coding width for all characters, 16 bits. A particular code of character is always unique. Difference between Unicode and ASCII. Unicode is generally form of coding scheme for numerous characters of different scripts, whereas ASCII code is specific coding scheme used for limited characters. Unicode represents higher range of codes, whereas ASCII code represents limited range of codes. So that character data type, if you declare this character 1, character 2, character 1, if you store 88 code for X and character Y, then system out println. And if you want to store, for example, X, this is 88, X for 88, and system out println, this you will get output as X and Y, because X character code is 88 for X. If you see this table, ASCII table, this is character code for 88. See, decimal 88 is for X. If you observe carefully, if you want character X, and if you want to represent it in number without giving single quote, this is X. See, this X 88. This is numeric value for representing X. Means 0 to 127. If any number, if you mention, particular character is assigned for it. For example, instead of 88, if you give 89, this will be Y. This will be Y. This I would like to, character 1 is X, character 2 is Y, but here by numeric representation I am mentioning character. This is by character representation I am mentioning character. Let us go to our Eclipse again. So that character 88, and character 2 will be our as usual Y, and print this plus this, character 1, and another is plus character 2. What is possibility of printing? First we'll print ch1 xx, and then ch2 is y. Here, see the output, x and y. But here I am giving 88. Character is assigned with 88 integer. 88 is integer. So that 88 is used for x, representing x in character. And here it is 99, 89, sorry, is for y. So that instead of character representation, in integer representation, if I would like to represent it, so that put here 89 and just see, just run this, one and the same, x and y is printed here. Okay. Non-primitive or reference data types. The reference data types will contain memory address of variables value, because reference types would not store the variable value directly in the memory. They are string, objects and arrays. Literals are integer literal, but it is not int. Literals are constant in Java program. Java literals are classified under integer literal, real, character, string, boolean, null. Here integer does not mean int, not int, integer. In literals of this reference or non-primitive, integer is class, real is class, character is class, string is class, boolean is class, null is class. In primitive, they are different. Int is not class. Character, chr, not class. Here in non-primitive, these are classes. Integer literals, the number which are represented without decimal point, they are whole number have positive or negative values. And for example, this is a to indicate this. Difference in primitive, non-primitive. Primitive take a direct memory location. Non-primitive doesn't take. Non-primitive go through reference of object, where that object is stored, that data will get stored. Real literatures are also called as floating point constant, and they represent number with a decimal points. For example, this character, the constant which are alphanumeric in nature and called as character. All literals, letters, capital, small digits, special symbols can be termed as character letters. For example, A, D, 3, etc. All this. Character literals represent single character enclosed within a single quote. These are escape sequence, octal, hexadecimal, single, double, backslash, carriage, new line, form feed, tab, backspace. Using escape sequence, for example, system out println, Rugved, age 14, class 10, like a name, age, class. Using escape sequence, this will be used for backslash t, and this character is used to separate values while printing them on the screen. It will provide gap of 8 spaces between them, and it is called as tab spacing. It acts similar to tab keys when passed on the keyboard. For example, integer a equal to 4 and b is 5, and first number is a, and tab you want between slash t you do, and then second number, this tab will be there. First 4, second 5, tab space will be there. Similarly, this slash, backslash, double quotes, it is used to with system out println statement when you want to display the message to screen, in which you say that part of it needs to appear under double quotes. So that somewhere I want this double quote. Welcome to Java internship. So that in a Java internship, I need Java internship with double quote, so that backslash double quote you provide. Simple double backslash is used to insert backslash at the point of its appearance in a message or the output used with system out println system. The first backslash is used as a command, whereas the next backslash is used as the character to appear in the text. So that this slash, yes, and this slash. The string is a set of alphanumeric character, group of character enclosed with a pair of opening and closing double quote is known as literals, such as computer in double quote is string, here in double quote in string, 10% per annum in a double quote is string. Then Boolean constants are specially, they represent true or false and can be used in Java program to check whether the given logical condition is satisfied. Or you must note that Boolean constant true or false are never enclosed within the quotes, and this character makes Boolean constant different from string constant. Null literals, this is also special purpose literals. It is represented as null, each letter in lowercase, and is used to initialize an objects or reference variable. Open eyes and read this. During this session, you got this, like we have seen primitive data types like byte, their range. How to calculate their range, that also we have seen. Short, their range, and how to calculate their range with 2's complement, their power. Byte is of 1, short is of 2, integer of 16, long is for 64, character is again 1, float is 32, double is 64, boolean is a single bit. All this is we have seen, and how to calculate this also we have seen in detail, along with boundary condition of program we have seen in Eclipse, how to run, how they gives error if you exceed the boundary condition, that also we have seen. Then also non-primitive data type also seen. Difference between primitive and non-primitive are, primitive will get stored in a memory variable by variable, and non-primitive will get stored by reference value of their object. Literals of non-primitive data types also we have seen. Be ready for next session. Session number 3 will be on variables and type conversion and casting.